Neha, let's put the book away, please. Let's get ready to take notes by taking out our math notebooks. And we are moving right along in Chapter 7. In fact, we're almost at the end of Chapter 7. We've learned how to multiply fractions with whole numbers. We've learned how to multiply fractions with fractions. And finally, we're learning how to multiply mixed numbers today. Okay? So this is Chapter 7.9. And your learning goal is to multiply mixed numbers. But first, of course, let's talk about the problem of the day. Now, our problem for today, it says 1/3 of a park that's 1 1/4 acres has been reserved as a dog park. Okay, so how big is the park altogether? Yeah, the whole park altogether is 1 1/4 acres. But is all of it a dog park? No, only how much of that? Only 1/3 of the 1 1/4 acres is a dog park. The question's asking us to please find the number of acres that are used as a dog park. So let's start with what we know, okay? If I'm finding 1/3 of 1 1/4, what math sentence is that? 1/3 times 1 1/4. Now, we've already learned how to use a model. So go ahead in your notebook and write 1/3 times 1 1/4. And then draw a model that shows 1/3 times 1 1/4. 1/4, right? So I'm going to shade in this whole thing for the 1 part. And how much of this other section should I shade in? 1/4. So in red I've shaded in 1 1/4. But is all that red section the dog park? No, only the 1/3 of it. So I have to divide it into how many parts? 3. And divide the whole thing into 3. And I'm going to color in 1/3 of that in blue as well, right? So now 2 colors, the parts that have 2 colors is 1/3 of the 1 1/4. Would you agree? Yeah, we've learned this before. Now the question is asking what fraction of each rectangle is shaded twice? What fraction of this rectangle on the left is shaded twice? 4 out of how many total sections? 4/12, otherwise known as 1/3, yeah. Now how much, 4/12 of this one is shaded in. What about this one? How many sections are shaded in twice? 1/12, right? So over here I have 4/12 and over here I have 1/12. Altogether, how many 12ths are shaded in twice? Yeah. 4/12 plus 1/12 equals 5/12. So 5/12 represents all of the parts in these two rectangles that are shaded in twice. You can also rename the mixed number as a fraction. Okay, so let's take a look. Is 1/3 a mixed number? No. Is 1 1/4 a mixed number? Let's improperize it. Let's turn it into an improper fraction. How can I turn 1 1/4 into an improper fraction? Adam?
So I know that 1 equals 4/4.
Ah.
But if it's 1 1/4, that equals 5/4.
All right, so we can think in our head. Let me draw a little thought bubble here. We can think in our head that 1 1/4 is the same as 4/4 plus 1/4, right? And so how many fourths is that altogether? 5. So therefore, we know that 1/3 times 1 1/4 is the same as 1/3 times 5/4. Now are we ready to multiply the numerators and the denominators? Yeah, so 1 times 5 is, and 3 times 4 is 12. Do we get the same answer if we do it the first way and the second way? Yeah. So our problem that we're writing down in our notebook is 12 times 2 1/6. Now, in order for us to figure out if our answer is reasonable, let's think to ourselves. Let's think about how the product should be compared to the factors, okay? Is 12 times 2 1/6, is that going to be greater than, less than, or equal to 12? Right. So we'll know our answer is reasonable if it is greater than 12. Okay. Do you guys remember on the quiz where it asked you, describe how you know your answer is reasonable? That's what I want to hear. I want you to say like, oh, I know my answer should be greater than the factor or should be less than the factor. Therefore, I know my answer is reasonable. Okay? Now, our second step is to write the whole number and the mixed number as fractions. Go ahead and do that in your notebook. Rewrite this problem 12 times 2 1/6 so that both the whole number and the mixed number are fractions. Go. Change 12 into a fraction. Daniel? How do I change 12 into a fraction? Yeah, 12 over 1. Okay, how can I change 2 and 1/6 into a mixed, or this from a mixed number into an improper fraction? Ashi? Mm-hmm. Yeah, so it's 1 plus 1 6, right? Which is 6 6 plus 6 6 plus 1 6. Exactly. So how many sixes is that? 13 6? Good. Okay, so now we can multiply the numerators and the denominators. Now, some of us were talking about something called cross canceling, okay? And what that means is you can look in these diagonal lines like this, and you can see if there's any common factors. Do 1 and 13 have any common factors? 1 and 13, but that's not going to help us, okay? What about 6 and 12? Do they have any common factors?
6.
What do they have?
6.
6. Okay, so what I can do is I can cross them out, and I can divide them both by 6. So what's 12 divided by 6? So I can replace the 12 with a 2, and I can replace the 6 with a 1, because 6 divided by 6 is 1. Now it's much easier for me to multiply, right? Because I don't want to do 12 times 13 in my head, but I can do 2 times 13 in my head, right? So now let's multiply. 2 times 13 is? 1 times 1 is? 1. So that actually saves us a lot of steps because now we know our answer is? I want you to write in your notebooks, we're multiplying 16 times 4 and 1/8. Write it down. And we're going to use the distributive property to help us solve it. Okay, so 16 times 4 and 1/8 is the same thing as 16 times what plus 1/8? Colin? 4. Go ahead and write this down. Now, of course, we have to distribute the 16 to both the 4 and the 1/8. So that's equal to 16 times 4 plus 16 times 1/8. And now we can do this in our head. 16 times 4 is? 64. And 16 times 1/8 is 16 over 8, which is 2. So 64 plus 2 is? 66. So we can see how sometimes distributive property helps us break apart the whole. We multiply the whole number part first, right? First we multiply the whole number part. Then we multiply the fraction part. And then we add them together.